Gold in rivers almost never appears where people expect it. Most beginners search the brightest water, the easiest ground, the most obvious places, and that's exactly why they miss it. Because rivers don't scatter gold randomly, they concentrate it, quietly, slowly, following hidden physical laws most people never think about. And once you understand how moving water controls gold, rivers stop looking ordinary. Every bend becomes a clue. Every exposed rock becomes part of a larger system. Every change in water flow starts revealing where heavier minerals may be hiding. By the end of this, you're going to understand how rivers naturally trap gold, why certain spots quietly collect heavy minerals over time, and how experienced prospectors read landscapes long before they ever touch the water. Because gold discovery in rivers is not about luck, it's about understanding movement. At first glance, rivers seem chaotic. Water rushing through channels, sediment moving constantly downstream, rocks scattered randomly across riverbeds. But rivers actually behave with incredible consistency, especially when it comes to heavy materials. And gold is one of the heaviest natural metals found in river systems. This changes everything, because when water moves sediment downstream, lighter material travels farther and faster. Sand moves easily. Small gravel shifts constantly. Organic material drifts with the current. But gold behaves differently. Its density makes it resistant to movement, which means rivers naturally begin separating gold from lighter materials over time. This is the beginning of placer gold formation. And understanding this process allows geologists and prospectors to predict where gold may settle long before visible gold is ever seen. Now here's the part most people misunderstand. Gold does not simply remain wherever it enters the river. The river itself controls where the gold eventually stops moving. Every bend, drop, obstruction, crack, and pressure change affects water velocity. And whenever water suddenly loses energy, heavier materials begin dropping first, including gold. This is why experienced prospectors pay attention to river structure more than surface appearance. Because gold follows hydraulic behavior, not visual beauty. Now imagine a river moving rapidly downhill. The current carries sediment through narrow channels at high speed. But then the river suddenly widens, the water slows, its carrying power weakens, and heavy materials begin settling downward. This creates one of the first natural gold traps. But rivers create many others: large bedrock cracks, inside bends, natural riffles, behind boulders, at the base of waterfalls, along ancient flood channels. Each location changes water velocity differently, and each one can quietly collect dense materials over long periods of time, including gold. This is why river gold often appears in concentrated pockets rather than evenly spread across an entire stream. The river sorts materials naturally, almost like a machine operating continuously over thousands of years. And perhaps the most fascinating part is this. Most river gold originally came from somewhere else. Long before the gold reached the river, it often existed inside quartz veins buried deep underground. Over immense spans of time, erosion slowly broke those systems apart. Rain, temperature changes, flooding, rock fracture. Tiny gold particles escaped from ancient host rock and entered drainage systems. And once inside rivers, the river itself took control, transporting the gold, sorting it, concentrating it, hiding it in places where water energy weakened enough for dense particles to settle. This is why understanding the surrounding geology matters just as much as understanding the river itself. Because rivers are only part of the story, the source of the gold matters too. A river flowing through barren geology may contain almost no gold at all, but a river cutting through ancient hydrothermal zones, quartz systems, greenstone belts, or mineralized fault structures becomes far more significant. This is why professional prospectors study entire landscapes, not just water. They examine exposed bedrock, quartz veins, iron staining, sulfide minerals, structural corridors, ancient erosion pathways. because rivers often preserve clues connected to geological systems hidden far upstream. And this is where observation becomes incredibly powerful. A dark streak of black sand collecting behind a rock may indicate heavier minerals settling from the current. An exposed bedrock crack may act like a natural trap for dense material. Rounded quartz fragments in stream gravel may suggest upstream vein erosion. Each clue adds information, and slowly, the river begins revealing its hidden behavior. But rivers also change constantly. Floods rearrange sediment. Storms open new channels. Old deposits become buried while new concentrations form elsewhere. Which means river gold is dynamic, always moving, always responding to water energy and landscape change. This is why experienced prospectors never rely only on surface appearance. They think in terms of flow dynamics. Where was water moving fastest? Where did velocity suddenly drop? Where would dense material naturally settle? These questions matter far more than random searching, because gold follows physics and rivers obey patterns. Now, perhaps one of the most overlooked parts of river gold discovery is bedrock. Many beginners focus only on loose sediment, but experienced prospectors often pay close attention to exposed bedrock beneath the river itself, because bedrock traps gold exceptionally well. Cracks, crevices, depressions, and rough surfaces create low-pressure zones where heavy particles settle and remain protected from further movement. Over time, gold can accumulate in these hidden spaces while lighter material continues washing away. And sometimes, the richest concentrations exist where almost nobody thinks to look. This is why rivers can appear empty on the surface while still hiding significant material deeper below. But perhaps the most important lesson is this: gold rarely announces itself directly. The river does not point toward treasure. Instead, it quietly reveals patterns, flow patterns, sediment patterns, erosion patterns, geological patterns. And once you understand those systems, rivers stop looking random forever. Every bend becomes meaningful. Every exposed rock becomes evidence. Every black sand deposit becomes part of a much larger process shaping the landscape over immense periods of time. Suddenly, the river transforms into a geological map written in motion. But rivers are only one environment where gold hides, because some of the richest hidden systems exist far away from flowing water entirely. In harsh desert landscapes where erosion exposes ancient rock structures directly at the surface. And unlike rivers, desert gold rarely glitters openly. It hides behind subtle rock textures, color changes, exposed fault zones, and forgotten geological patterns most people completely overlook, which is exactly what we're exploring in the next video. Because in the next episode, we're going to uncover how experienced prospectors quietly read desert landscapes to identify where hidden gold may already exist beneath the surface. Most people walk across deserts thinking they are empty. But deserts are not empty, they are exposed. They strip the earth down to its memory. And when you understand what the ground is quietly revealing, you realize something remarkable. Gold, silver, and platinum do not hide randomly. They follow symmetry. They leave patterns. And deserts, more than any other landscape on Earth, reveal those patterns clearly, if you know where to look. Gold, silver, and platinum are often treated as separate metals, born from different worlds, valued for different reasons. But beneath the surface, they are connected by the same geological forces: pressure, heat, fluid movement, and time. In deserts, those forces are no longer buried beneath vegetation, soil, or water. They are written directly into stone. Dry climates preserve geological truth. Rain does not wash it away. Plants do not cover it. Erosion works slowly, honestly. And this is why some of the world's richest precious metal discoveries were not made in forests or valleys, but in places that looked lifeless. Gold forms when hydrothermal fluids move through fractured rock deep underground. Those fluids carry dissolved metals, rising slowly until pressure drops and the metals are forced out of solution. Gold settles first, heavy and stubborn, locking itself into quartz veins, shear zones, and fault lines. Silver often travels with it, but farther. Silver remains mobile longer, spreading outward into surrounding rock, staining the earth subtly. In desert terrain, this silver does not rot away. It oxidizes. It turns stone faintly gray, green, sometimes blue-black. Not bright, not obvious, but consistent. Platinum forms even deeper. It originates in ultramafic rocks, ancient magma bodies that cool slowly beneath the crust. Over millions of years, tectonic movement pushes fragments of these rocks upward. Deserts expose them. Dark, dense stones, heavy underfoot, often ignored. Yet these rocks tell the same story: extreme pressure, ancient origin, and metal concentration that cannot be recreated. In deserts, the absence of soil becomes an advantage. You can see fault lines clearly, long, straight scars cutting through rock. These fractures are not random. They are pathways. Gold loves pathways. Silver follows them outward. Platinum hides near their roots. Quartz becomes a language here. White quartz veins cutting through darker host rock are not decoration. They are evidence, especially when the quartz is fractured, iron-stained, or broken. Rust colors are not decay. They are oxidation halos, the ghost of metal that once moved through that stone. Desert quartz often looks ugly, cloudy, broken. Veins that seem worthless. Those are the dangerous ones, because perfect quartz rarely carries value. Broken quartz means movement. Movement means opportunity. Silver announces itself differently. In deserts, silver often appears where rock looks slightly wrong. Darkened patches, greenish tints, stones that feel lighter than expected. Silver minerals oxidize near the surface, and the desert preserves those oxidized skins like fingerprints. Platinum is quieter. It does not stain brightly. It does not sparkle. It hides in heaviness, in rocks that feel denser than they should be, in black sands left behind after wind removes everything lighter. Desert washes, dry riverbeds, are critical here. Even without water, gravity still sorts material. Heavier metals sink. Over time, wind replaces water. The same physics apply. Platinum, gold, and sometimes silver collect in subtle traps, behind rocks, in bends and depressions where motion slows. This is symmetry in motion. Gold settles closest. Platinum settles deeper. Silver spreads wider. Different behaviors, same rules. One of the strongest desert indicators is repetition. One strange rock means nothing, but a pattern means everything. Quartz appearing again and again. Rust colors repeating along a line. Dark, heavy stones clustered unnaturally. Nature repeats what works. Deserts allow you to see repetition without distraction. And this is why modern prospectors often fail. They search for shine instead of structure. They chase surface glitter. They ignore geometry. But geometry never lies. Straight lines in nature are rare. When you see them, they matter. Faults, veins, contacts between rock types, boundaries where pressure once changed. Gold respects boundaries. Silver leaks across them. Platinum anchors below them. In deserts, these boundaries are exposed like pages torn from the Earth's diary. Even color matters. Reddish-brown rock indicates iron oxidation, often associated with hydrothermal activity. Pale, bleached zones suggest chemical alteration. Greenish stains may hint at copper, which often travels alongside silver and gold. None of these signs guarantee metal, but together they speak. Deserts do not whisper loudly, but they never lie. And here is the symmetry most people miss. Where you find gold indicators, silver is rarely far. Where silver spreads wide, platinum often lies deeper nearby. Different depths, different expressions, same origin story. This is why some desert regions produce all three metals over time. Not at once, not obviously, but inevitably. The Earth does not waste effort. When conditions are right for one, they are often right for all. Deserts did not always look this way. What appears dry, lifeless, and still today was once shaped by water, pressure, and motion on a massive scale. Long before sand dominated the surface, rivers carved through rock, oceans advanced and retreated, and mineral-rich fluids moved freely beneath the crust. This matters because gold, silver, and platinum are not just products of heat and pressure, they are also products of movement. In many desert regions, ancient river systems once carried enormous energy. When climate shifted and water vanished, those rivers didn't disappear completely. Their paths hardened into stone, their beds became dry washes, their curves became silent traps. And heavy metals never forget gravity. Gold, silver, and platinum responded to those ancient flows exactly the way physics demands. Gold dropped first, heavy and decisive. Platinum followed, denser still, sinking deeper into natural depressions. Silver traveled farther, lighter and more willing to scatter, coating surfaces and seeping into fractures. Today, deserts expose these systems without disguise. Dry washes, arroyos, and paleochannels, ancient river paths now frozen in place, are among the most honest geological storytellers on Earth. They reveal sorting, they reveal concentration, they reveal symmetry. When you examine a desert wash closely, the clues are subtle but consistent. Heavier material concentrates on the inside bends. Black sands gather where motion once slowed. Angular quartz fragments indicate proximity to source rock, while rounded stones suggest long travel. Platinum often hides here, not visibly but physically. It resists weathering. It survives where lighter minerals are carried away. Gold behaves similarly, though it often lodges slightly upstream, caught in cracks and natural riffles formed millions of years ago. Silver, meanwhile, leaves its presence in the walls. Oxidized silver minerals stain surrounding rock. Faint grays, dull greens, sometimes barely perceptible unless the light hits just right. In desert sun, those hints are not washed away. They remain preserved, waiting. This is why desert prospecting rewards patience over excitement. Shiny distractions fade quickly here. Structure endures. Another critical factor deserts reveal is contact zones, the boundaries where different rock types meet. These are not just geological curiosities. They are stress points, pressure changes, chemical reactions. Gold and silver love these boundaries. Platinum respects them. When magma intrudes into surrounding rock and cools, it creates a chemical conversation between host rock and intrusion. Metals precipitate along these borders, especially where fractures allow fluids to move repeatedly. In desert terrain, contact zones are exposed cleanly. You can often walk them, see the color change underfoot, feel the density shift, hear the sound difference when stone strikes stone. This is not romantic language. This is physical reality. Rocks formed under different conditions respond differently to erosion. Deserts strip away the softer layers and leave the harder truth behind. Ultramafic rocks, dark, dense, magnesium-rich, are especially important for platinum. They weather slowly. They stand out. They feel wrong in the hand, heavier than expected, colder, resistant. These rocks are rarely appreciated by casual observers. They lack shine, they lack beauty, they lack obvious reward. Yet they are among the oldest materials on the surface. Time favors density. Gold's relationship with deserts is equally revealing. Because deserts do not replenish sediment quickly, placer deposits remain stable for extraordinary lengths of time. Gold that settled millions of years ago may still sit within inches of where it first stopped moving. This is why deserts can hold wealth that appears untouched, not because it was ignored, but because it was never visible to those who didn't understand the signs. Silver behaves differently over long desert timelines. Because silver oxidizes readily, it often forms secondary minerals near the surface. These minerals can leach, redeposit, and stain surrounding rock repeatedly over thousands of years. Deserts preserve these cycles like layers in a book. One stain means little. Repeated alteration means history, and history is where symmetry becomes undeniable. Gold, silver, and platinum respond to the same stress events: tectonic shifts, magmatic intrusions, erosion cycles, climate transitions. They separate by behavior, but they reunite by cause. This is why regions known for gold often later reveal silver. Why silver districts sometimes surprise with platinum. Why the Earth rarely offers one without hinting at the others. Symmetry does not mean equality, it means alignment. Even wind plays a role here. In deserts, wind acts as a sorting mechanism, slowly removing lighter material and leaving heavy components behind. Over centuries, this creates lag deposits, concentrations of dense minerals at the surface. Gold can appear this way, platinum even more so. Silver's contribution is subtler, but it often marks the zones feeding these concentrations. These processes are quiet. They do not announce themselves, but they never stop. This is why understanding geology restores patience. You stop chasing excitement. You stop expecting instant reward. You begin to read, and reading the land changes how you think. Not just about metals, but about value itself. Gold, silver, and platinum are valuable because they obey rules that human systems cannot break. Scarcity, density, irreplaceability. Time. They do not respond to trends, they respond to physics. Deserts teach this lesson better than anywhere else. Nothing is hidden behind excess. Nothing is softened by growth. Nothing is disguised by comfort. What remains is structure, and structure is where truth lives. As we step back and look at the symmetry between these metals, how they form, where they settle, how they reveal themselves, we see something deeper than geology. We see consistency in a world that pretends to be chaotic. Gold anchors value, silver spreads function, platinum enforces necessity. Different roles, same foundation. This is why civilizations return to them again and again. Why modern systems still depend on them. Why deserts, silent, patient, exposed, continue to hold answers most people overlook. And this brings us to the truth most never hear. The Earth does not hide wealth to be cruel. It hides it to be selective. Only those who slow down, observe patterns, and respect structure are rewarded with understanding. Not excitement, understanding. Because when you recognize the symmetry between gold, silver, and platinum, you stop asking what is valuable. You start asking what is inevitable. And inevitability, whether in geology or in human systems, has always been the most reliable signal of all. This is not about finding metal. It is about learning how the Earth thinks. And once you understand that, deserts are no longer empty places. They are open books, written in stone, patiently waiting for those who know how to read.